How to measure recursive algorithm with multiple calls. Now in the last lecture we have looked at how to measure recursive algorithm by examining these functions over here. So we have found that the time complexity for this function is on. Now in this lecture we will look at tricky recursive call which calls itself twice. So here we have a function which takes as a parameter integer. So in this function the first condition is we are checking that if n less or equal to 1 then we are returning 1, otherwise it calls itself with the parameter of n-1 twice, and we are summing up these values and returning them. This function is similar to the function that we discussed in previous lecture. The difference over here is the function calls itself twice, and then we are summing up the result. Many people might think that if in case of previous function over here, if the time complexity was on, where the function calls itself once, so here it calls itself twice, so we can write on squared time complexity. But this assumption is completely incorrect. Rather than making assumptions, let's drive the runtime by walking through the code. Suppose we call this function for the parameter of 4. When we call this function with the parameter of 4, it's going to call itself twice with the parameter of 3. Then with the parameter of 3, it's going to call itself twice over here and over here also with the parameter of 2. Then with the parameter of 2, it's going to call with the parameter of 1 8 times over here. So how many calls are there in this tree? So you don't need to count them, because if you do so, you will get 15. So what does this number tell us? So if you look at this tree over here, we see that the depth of this tree is 4. So 0, 1, 2, 3. So this means that if we start from 0, the depth is 4. So here in level 0, we have only one node. Then in the level 1, we have 2 nodes. In the level 2, we have 4 nodes. And in the level 3, we have 8 nodes. So I have put everything in this table over here. So you can see that in the level 0, we have only 1 node. In level 1, we have 2. And in 2, we have 4. And in 3, we have 8. And these ones can be expressed as the power of 2. So in case 1, it's going to be 2 to the power of 0. In case 2, 2 multiplied with the previous level that comes from 2. So it's going to be 2 multiplied with 2 to the power of 0. So it's 2 to the power of 1. Then in level 2 we have 2 multiplied with the value that comes from previous level. So in the previous level we have 2 to the power of 1. So 2 multiplied with 2 to the power of 1 is going to be 2 to the power of 2. Then we are continuing in the third level. So by calculating same way we are getting 2 to the power of 3. So if we sum up the number of nodes in this level over here, we will get 15, which is the number of calls we count from here. So from math we know that if we calculate the sum of power of 2, we can write the equation like this. So and this equals to 2 to the power of n-1. If we take in terms of time complexity, we can remove the constant from here and we can write it as like this, or 2 to the power of n. So from this equation, we can come to the conclusion that when you have a recursive call that makes multiple calls, the runtime will often look like this. So O branches to the power of depth. So in our case, the branches is 2 because each time when we call recursive function, it calls itself twice. So here you can see that we have 2 branches for each call, and the depth is in our case is 4 for example for this case. So it means that the time complexity will be in this case 15, but if you put n there, the time complexity will be 2 to the power of n. So hopefully with this example you have understood how can we find time complexity for a recursive call which calls itself multiple times. So here it actually depends on the times of calls that it makes for itself and depth of this tree over here. So with this we have come to the end of this lecture. So see you in the next lecture.